Hi everyone. In this video, we are going to discuss about the various types of equations of straight line that represent a group of straight lines or a set of straight lines or a family of straight lines instead of a single straight line. What is the most common equation of straight line that we know? Well, it's the slope-intercept form, which is like this: y equals mx plus b. Some authors might call it as y equals mx plus c, but whatever it is, m is the slope and b is the y-intercept. Also, we know the general equation of a straight line is kind of like this. In the slope-intercept form, looks like there are two unknowns, m and b. Those are the two unknowns there. However, in the general form, it looks like there are three unknowns, like the a, b and c. Well, even though it looks like there are three unknowns, we can easily convert this form into the slope-intercept form, and ultimately we'll see that there are actually two unknowns instead of three unknowns. So let's quickly convert it. So the general equation of the straight line can be easily converted into y equals mx plus some constant form, right? Whether it's b or c or k doesn't really matter. It always represents the y-intercept. But I wanted to show you how the general equation can be converted into the y equals mx plus b form. Now in this case, obviously m is represented by negative a over b and k is represented by negative c over b. So we can see that no matter whatever is the form of the equation of straight line, we can easily convert it into y equals mx plus b form, and that is the most popular form which is widely used in solving problems in geometry and coordinate geometry. So as you can see, in the y equals mx plus b form, there are two unknowns, m and b. Right? Now, if we are given two conditions or two sets of information through which we can form two equations to solve the two unknowns, then we can come up with the equation of a particular straight line. However, if we are given only one set of information so that we can transform this equation into y equals some slope times x plus b form, kind of like this. Let's say y equals 2 times x plus b form, right? In this case, you see there is one unknown which is the b, that's the y-intercept. Slope has been provided which is positive 2. Now if we are given an equation like this without any other information, what would it represent? Would it represent a particular straight line or would it represent a set of straight lines or a family of straight lines? Well, if you think about it, we can use different values for b and then come up with different equations of straight line. That means by changing the value of b, we can draw various straight lines. However, all those straight lines have a common nature. And what is that common nature? Well, that's the slope. Each straight line will have the same slope, which is positive 2. However, their y-intercept will be different. So how are they going to look like then? Well, they will kind of look like this. Let me draw a few straight lines on the chart here. So all of those straight lines will be parallel to each other because they have the same slope. However, their y-intercept would be different, any arbitrary number that you can use for b, right? So using different values of b, we can come up with a whole bunch of straight lines, actually infinite number of straight lines. They all will be parallel to each other, but their y-intercept will be different. So this particular form of the equation y equals 2x plus b, where there is one unknown which is the b, they actually represent a set of straight lines or a family of straight lines. And here, since we are able to vary or we are able to take different values of b, b will be called the parameter. So this is a parameter that we can change and thereby we can come up with different equations of straight lines. However, they all will have the same slope of positive 2, but their y-intercept will be different depending on the value of b. So in this case, b will be called the parameter. And this particular form would represent a family of straight lines with the same slope but different y-intercept. And that was the first form that we wanted to discuss in our video. So the family of lines with a given slope, that means a family of parallel lines, can be represented by an equation like this: y equals some known slope times x plus some unknown b, which is the unknown y-intercept. Next, we are going to take a look at another family of straight lines. So now let's take a look at the equation of straight line that would represent the family of lines through a given point. And that equation is going to look like this: y minus y sub 1 equals m times x minus f sub 1. Here m is the slope, x sub 1 and y sub 1 are the coordinates of the given point. So x sub 1 and y sub 1, they will be given values and m will be the parameter in this case. From here you can imagine that we are talking about a group of straight lines that have different slope, but they all go through a particular point. Now if I take that point as, let's say, 5, 5, so in my chart here the point will be kind of like here. I'm putting a red dot right here, that is 5, 5, and now the equation is going to look like this. So this equation will represent a set of straight lines which are all going through that particular point 5, 5, but they have different slopes. So let me draw a few straight lines through that point and let's see how they look like. So the straight lines are going to look like this. They all are going through the point 5, 5, which I have denoted with a red dot right there, and they have different slopes. So they all are intersecting straight lines. They all go through the same particular point, which is 5, 5, and that 5, 5 is right here actually, this y sub 1, that's the y coordinate, and x sub 1, that's the x coordinate. I have denoted that with 2 red underscores here in the equation. So 5, 5 is the point through which all of these straight lines will be going through, but they have different slopes. So using different values for m, we can come up with various equations, but the beauty is that all of those straight lines will go through that particular point. So now let me highlight the general form of that equation, which is y minus y sub 1 equals m times x minus x sub 1, where x sub 1 and y sub 1 will be given, m will be the unknown, that's the parameter, and a sample equation will look like this, the one that I have here, y minus 5 equals m times x minus 5. Next we are going to talk about the family of lines parallel to a given line. Let's suppose we have been given the equation of a straight line like this. Then the equation of the family of straight lines which will be parallel to this given line will look like this, where a and b will be given and k will be the unknown. Now I'll quickly explain why is it like this. In fact, this topic is very similar to the first topic that we discussed, the family of straight lines with a given slope and unknown y-intercept. This particular form is also exactly like this. Let's make a quick note here and then we'll discuss how it is similar to the first topic. Let's try to convert the given equation in y equals mx plus b form. So our given equation is ax plus by plus c equals 0, and from here we can rewrite it like this, and then if we divide both sides by b, we are going to get y equals negative a over b times x minus c over b. And if we convert our new equation, which is ax plus by plus k equals 0, we can rewrite it like this, and if we divide both sides by b, then we are going to get y equals negative a over b times x minus k over b. Now if you look at both of these equations, negative a over b is the slope. So to come up with the equation of a straight line which will be parallel to a given line, we have to make sure that the slope is same, and that's exactly what we see here, that ax plus by plus c equals 0 and ax plus by plus k equals 0, both of these equations are actually having the same slope. So with this new equation, which is ax plus by plus k, it is nothing but a straight line which is parallel to the given line, which is ax plus by plus c equals 0, because we are maintaining the same slope. It's just the look and feel is different, but ultimately we are maintaining the same slope. So ax plus by plus k equals 0 is representing a straight line which is parallel to the given line ax plus by plus c equals 0. The only thing that is different is the y-intercept. In the first equation it is negative c over b, and in the second equation it is negative k over b. Now in the first equation, please understand that all of these unknowns there, a and b and c, they all will be provided because we are going to be provided with the equation of a straight line. So a, b and c, they all will be known numbers. However, when we come up with the equation of family of straight lines which will be parallel to the given line, in that form a and b will obviously be given. However, k will be the unknown, right? So a will be given, I am doing a pink underline, b will be given, but k will be the unknown. Let me do a yellow underline here. So k will be the unknown, and that will be the equation of the family of straight lines which are parallel to the given line. Let's take an example. Suppose we have been given the equation like this, x minus y plus 5 equals 0. Then what would be the equation of family of straight lines which will be parallel to this given line? Well, the equation will look like this. The x and y terms will look exactly identical, but the constant term will be represented by a parameter. So this will be the equation of the family of straight lines which are parallel to the given equation x minus y plus 5 equals 0. The trick here is that to come up with the new equation, you want to copy the x and y terms ditto, meaning exactly how they are in the given equation. So in this case it is x minus y, so I kept it as x minus y in the new equation, and then you simply want to replace the constant term with the unknown parameter k. So this form or this new equation will represent the family of straight lines which are parallel to the given line x minus y plus 5 equals 0. We can take one more example. Suppose we have been given the equation like this: 2x plus 3y minus 10 equals 0. And what would be the equation of the family of straight lines which are parallel to this given line? Well, they will be exactly like this. It would be 2x plus 3y plus k equals 0. Here also you can see how we have created this new equation. We pretty much kept the x and y terms as is, like 2x plus 3y, and then we introduced the parameter which is k. So this new equation would represent the family of straight lines which are parallel to the given line 2x plus 3y minus 10 equals 0. I hope things are making sense so far. Next we are going to talk about the equation of family of lines which are perpendicular to a given line. Say for example, we have been given the equation of a line like this: ax plus by plus c equals 0. That's a given equation. That means a, b and c, they are all known numbers, right? Nothing unknown in here. So a and b and c, they are all known numbers. And now we have to come up with the equation of a set of straight lines which will be perpendicular to this given line. And how would that equation look like? Well, it will be like this. To come up with the new equation, what do we have to do? Well, we have to use b as the coefficient of x, and then a negative sign, then a as the coefficient of y, and then some parameter k, and the sum of all of these would be equal to 0. So that is the equation of the set of straight lines which are perpendicular to the given line whose equation is in the blue color. Now if you are thinking, why is it like that? Well, let's try to find out the slope of the first line, meaning slope of the given line. So let's do a little bit of math here real quick. So we have ax plus by plus c equals 0, and from here we can write it as by is equal to negative ax and negative c, and dividing both sides by a b, we would get y equals negative a over b times x and minus c over b. So here we see that the slope of the given straight line is actually negative a over b. And now let's try to find out what is the slope of our new set of lines. Well, we have bx minus ay plus k equals 0. And if we convert it into y equals mx plus b form, then it's going to look like this. Now, what is the slope of this new equation here? Well, the slope looks like positive b over a. Since the new equation represents a family of straight lines which are perpendicular to the given line, then the product of the slope of the given line and the slope of the new set of lines would be equal to negative 1. If we have two perpendicular lines, we know that the product of their slopes would be equal to negative 1. So in this case, do we also see the same pattern here? Now let's multiply the slope of the given line and the slope of the new set of lines, right? So we had negative a over b multiplied by, we have positive b over a, and if we multiply this, you can clearly see that this is going to be negative 1. So the equation of the new set of straight lines, which we have as bx minus ay plus k equals 0, seems to be correct. Now let's take a couple of examples. Suppose we have been given the equation of a straight line like this. We have to now determine the equation of a family of straight lines which will be perpendicular to this given line, and the equation will look like this then. It would be 3x minus 2y plus k equals 0. Now what is this 3? Well, this 3 is actually this one right here. This is that 3. And what is the 2 here? Well, the 2 is actually this 2 right here. So this is like bx minus ay plus k equals 0. So this new equation would represent a family of straight lines which will be perpendicular to the given straight line. If we want to take another example, say suppose we have been given the equation of a straight line like this. Let's say x minus y plus 2 is equal to 0. And what would be the equation of the family of straight lines which will be perpendicular to this given line? Well, it would be bx minus ay, so that would be negative 1 times x minus positive 1 times y plus k is equal to 0. Now why negative x? Well, x will take the coefficient of y from the given equation. So coefficient of y in the given equation is negative 1. So in the new equation it is negative 1 times x, and then minus, it will take the coefficient of x from the given equation, and that will become the coefficient of y. In the given equation, the coefficient of x is positive 1, so we have minus sign, then positive 1 times y, that is negative y essentially, and then plus k equal to 0, and here obviously k is the parameter. By changing the value of k, we can draw n number of lines, or I mean infinite number of straight lines, but all of them will be perpendicular to the given straight line. I hope it is clear up to this point. Next, we are going to see how the equation of a family of straight lines is going to look like that have a particular given x-intercept. So suppose here we are talking about x-intercept as positive 2, for example, right? What is the intercept form of the equation of straight line? Well, it's kind of like this. X over a plus y over b equals 1, where a is the x-intercept and b is the y-intercept. Now in this case, suppose we are talking about a particular given x-intercept, let's say 2 for example. So then how would this equation look like? Can we rewrite it like this? We can say, well, x over 2 plus y over b is equal to 1. That would represent a family of straight lines that have an x-intercept of 2. In general, we can write it like this. We can say x over a when a is a given number plus y over k or y over b, whatever you like, is equal to 1. Now here a will be a given number and k will be the parameter. It's an unknown. And this equation in yellow, this will represent a family of straight lines that have an x-intercept of a. A could be a positive or negative real number, really does not matter. So as long as a is a known number but k is the unknown parameter, then this is going to represent a family of straight lines that have a particular x-intercept. Here I have drawn a few straight lines and all of them are going through a particular point on the x-axis. Let's assume that that's the given x-intercept, and then all of these straight lines equation can be exactly like this: x over a plus y over k equals 1, and k will take different value for these different lines, but a will be same for all of these lines. And let's assume that the coordinates of that point on the x-axis are a comma 0, so I am simply writing right here. So let's assume that that is a comma 0, that point, and that is the x-intercept, and in that case the equation of the straight lines would be x over a plus y over k equals 1. Now let's take an example. Say suppose we have been told that the x-intercept is 5 comma 0, then what would be the equation of the family of straight lines that will have the same x-intercept? Well, then it will be like this. We can write it as x over 5 plus y over k is equal to 1. We have been told that the x-intercept value is 5, so that's a known number that has been provided in the question, and then we had to come up with the equation of the family of straight lines, and the equation is actually like this: x over 5 plus y over k equals 1, where k is a parameter. By changing the value of k, we can draw all these possible straight lines that will be going through the point 5 comma 0. In this particular example, the x-intercept is at 5 comma 0, so by changing the value of k, we can come up with equation of all possible straight lines that will be going through the point 5 comma 0. And similarly, if we talk about a family of lines making a given y-intercept, then what would be the form of the equation of those straight lines? Well, it's going to be like this: x over k plus y over b equals 1, where k would be the parameter and b would be a given number, that's the given y-intercept. For example, if we have to come up with the equation of a set of straight lines which will be making a particular y-intercept of positive 5, then the equation going to look like this: x over k plus y over 5 equals 1. This will be the equation that will represent the family of straight lines that will be making a y-intercept of positive 5. Now let me draw a few lines making y-intercept of positive 5. Here in the diagram, I have drawn a few straight lines which are all making a y-intercept of positive 5. They all are going through the point 0, 5. Next, we are going to see how the equation of a family of straight lines at a given distance from the origin going to look like. And here we are going to be using the perpendicular form of the equation of straight line. Now what is the perpendicular form? Well, it's kind of like this. Let's suppose we have a straight line as in the diagram where its distance from the origin is OA, which is equal to p units, and OA makes an angle alpha with the positive direction of x-axis. Then the equation of this straight line is x times cosine of alpha plus y times sine of alpha is equal to p. And here if we assume that p is a given number and alpha is the unknown, then this equation will represent a family of straight lines which are always at p units distance from the origin. This equation, the equation in the yellow box, would represent all of those straight lines which are at a distance of p units from the origin. By changing the value of alpha, we can come up with the equation of all those straight lines which will be at a fixed distance of p from the origin. Now I am going to draw a few straight lines in the diagram to show you how they are going to look like. Let's suppose we have been told that all of the straight lines are at a distance of say 5 units from the origin. Then the equation going to look like this: x times cosine of alpha plus y times sine of alpha is equal to 5. And I'm going to draw a few straight lines to show you how they could look like. All of these straight lines in blue color, they all are at a distance of 5 units from the origin. And I have indicated the distance in pink colored dotted lines. Assuming that all of these distances are just 5 units, the straight lines are going to look like this, and their general form would be like this. Let me highlight with a pink box right here. X times cosine of alpha plus y times sine of alpha is equal to 5. So this equation is actually representing a family of straight lines which are all at a distance of 5 units from the origin. And in fact, by changing the value of alpha, we can draw infinite number of straight lines which all will be at a distance of 5 units from the origin. And finally, we are going to see how to determine the equation of a family of lines passing through the intersection of two given straight lines. Say for example, we have been given the equations of two straight lines, straight line A, whose equation is a sub 1 times x plus b sub 1 times y plus c sub 1 equals 0. And the straight line B, whose equation is a sub 2 times x plus b sub 2 times y plus c sub 2 equals 0. So we have been given these two equations. Now we have to find out what would be the equation of the family of lines that will be going through the intersection of these two straight lines. Now in the diagram, as you can see, I have the two straight lines here, and let's name the intersection of these two straight lines as, let's say, P. Suppose this is the point P. I have it as a pink dot right there. And now we have to find out what would be that general equation of all the straight lines, all possible straight lines that could go through this point P. First, let me write down how that equation going to look like, then I will show you how to prove it. The equation of that family of straight lines would be like this: a sub 1 times x plus b sub 1 times y plus c sub 1 plus k times a sub 2 times x plus b sub 2 times y plus c sub 2 equals 0. Now here a sub 1, b sub 1, c sub 1 and a sub 2, b sub 2, c sub 2, all of those are known numbers. They will be provided in the question, and the only unknown in this new equation is the k, which is the parameter in this case. So by changing the value of k, we can create all the equations for all those straight lines that will be passing through the intersection of these two given straight lines. Now how can we prove that yes, this equation actually represents the set of straight lines that will be passing through the intersection of the two given straight lines? Well, let's assume that the coordinates of the point of intersection of the two given straight lines, which is P, let's assume that the coordinates of point P are like this. Let's say alpha comma beta. Since both the given straight lines are passing through the point P, then each of those given equations would be satisfied by the coordinates of P, since P lies on each of those straight lines. So P's coordinates should satisfy the equation. So let's do that then. So I'm going to take the first equation now, and then I'm going to plug in alpha and beta in place of x and y. The first equation was like this, and if we substitute x and y with alpha and beta, it's going to look like this. And similarly, if we take the second equation, alpha and beta will also satisfy the second equation because P also lies on the second straight line. So then if we substitute x and y with alpha and beta, it's going to look like this. Since the new equation in the pink box represents a set of straight lines which are also passing through the point P, then the coordinates of P would also satisfy this equation. So let's calculate the left hand side of that new equation there. First, let me write down the left hand side of the new equation. Now let's plug in alpha and beta in place of x and y. So the left hand side now going to look like this: a sub 1 times alpha plus b sub 1 times beta plus c sub 1 plus plus k times a sub 2 times alpha plus b sub 2 times beta plus c sub 2. Now on the right hand side in the yellow box you can see that we have already proved that a sub 1 times alpha plus b sub 1 times beta plus c sub 1 equals 0. So here in place of this right here we can say this quantity is actually equal to 0, and similarly we have plus k times, again within the parenthesis the quantity that we have, that is also equal to 0. We see that in the second yellow box on the right hand side. So this quantity is also equal to 0. So we can say k times 0, and this is definitely equal to 0 plus 0 equals 0. So I am simply writing it as equal to 0. So see that now we have been able to prove that yes, the left hand side of our new equation is equal to the right hand side of that new equation. Right hand side is obviously 0 that we have in the pink box, and the left hand side quantity whatever we had, we are able to prove that when we use the coordinates of the point P, this equation satisfies. That means the coordinates of the point P are actually satisfying the new equation. And also if you carefully look at the new equation, it is an equation in x and y where the degree of x and degree of y is 1. So definitely it represents a straight line, or rather a family of straight lines. And now that we have been able to prove that the coordinates of the point P also satisfy the new equation, so definitely the new equation would represent all those straight lines that will be passing through the point P. And then how are those straight lines going to look like? Well, it will be all those straight lines that are passing through the point P. So let me draw a few of those sample straight lines. Here I have drawn a few straight lines in blue color, and all of those straight lines are actually the family of lines represented by this new equation. And if you want to see an example, we can take an example. Say suppose we have been given the equations of two straight lines like this: 2x plus 3y minus 13 is equal to 0 and x minus y plus 1 is equal to 0. Now we have to come up with the equation of the family of straight lines which will be passing through the intersection of these two straight lines. We have already seen that the equation of the family of straight lines passing through the intersection of two given lines would be like this. In this case it will be the left hand side of the first equation plus k times the left hand side of the second equation, and the sum of that would be equal to 0, and that is the answer. So when we are given the equations of two intersecting straight lines, we can come up with the equation of the family of straight lines that will be passing through the intersection of the two given straight lines. Like in this example, in place of k, if you use different real numbers, you will be getting the equation of each of those group of straight lines. So here k is the parameter. By changing the value of k, you can come up with the equation of the individual straight lines which are all passing through the intersection of the two given straight lines. I hope everything made sense. Thank you for watching. See you in the next video.